Hi, everyone. My name is Nacho Alonso Portillo. I'm a principal technical product manager in the Azure Database for PostgreSQL team. In this session, I'll be introducing a fantastic feature in which we keep investing to extend its scope and evolve its functionality. You're interested in this session if you're a system engineer, a developer, or a database administrator who is struggling with performance issues. Hey, welcome everyone. Welcome to the Dear Azure Database for PostgreSQL. Can you automate my index section, which I'm grateful to present today to all of you. So first of all, let's jump into the agenda. Um, Topics we will cover is an introduction to index tuning, the process of index tuning, explaining what it is about. What are the key features of this automatic index tuning capability that Azure Database for PostgreSQL has built in? I'll walk you through a demonstration to configure um, automatic index tuning and see how index recommendations are rendered, how you can access them, and how you can implement them. And then we'll walk through the value proposition of the feature and finally wrap up with the conclusion. Um, so as an introduction to index tuning, um, um, indexes significantly enhance the query performance by allowing quick data location and fast access to your data. Um, Indexes reduce, when properly configured, they reduce the need to scan more rows than those strictly needed from a table to satisfy a given query, making data retrieval more efficient. And indexes are also a crucial component of the database management system. And when they are correctly tuned to optimize the performance of your workload, your server requires less resources, and therefore you can keep the costs constrained. Um, what is exactly index tuning? Well, it's an iterative and continuous process which involves observing the workload you're running against your data and analyzing current database indexes to enhance their efficiency and effectiveness for better performance of your current workload. So during the index tuning process, um, you might need to create new indexes that could significantly improve the performance of certain queries by providing quick access to data in a database. You might also identify unused or duplicate indexes. Removing unused indexes or duplicate indexes helps streamline database management and enhances the overall system performance. And finally, you might need to alter existing indexes, and that might be necessary to adapt to changing data patterns and to optimize query performance. Also, in PostgreSQL, while creating or altering indexes using the concurrently clause, the process may fail and leave indexes in invalid state. Those indexes cannot be used by queries to seek for data. Those indexes need to be maintained by data modification language operations. So it's very important to identify those invalid indexes as soon as possible to either delete them if they are duplicate of some other valid index or rebuild them until the operation completes successfully and they become valid indexes which are usable by the whole system. Um, Now that we have an overview of what index tuning is about, let's put this in context because this automation feature, is provided inside Azure Database for PostgreSQL. Right, Azure Database for PostgreSQL is a managed database service that simplifies the deployment and management of PostgreSQL databases and comes with several features and capabilities which are managed for you and help make your life easier as a developer or as a database administrator. The service provides flexible configuration options. So it allows you to tailor your Postgres databases to specific business needs and to specific workloads. And it brings a lot of built-in features like the one we're discussing today. And the one we're discussing today, which is automatic index recommendations, supports robust index tuning to help you enhance the performance and efficiency of your databases and your workloads. The key features of automatic index tuning are that the system automatically analyzes uh, the performance of the queries that your workload is running and identifies potential indexes to optimize the execution times for better efficiency, to reduce latency, basically. It eventually emits index recommendations that aim to enhance the performance of the workload that was previously analyzed. And it simplifies drastically the management of indexes, which is a, a meticulous and time-consuming work, by automating the whole process of observing your workload, um, discovering the appropriate indexes to improve that workload, the performance of that workload, and it it basically reduces the manual effort and improves the overall database performance. Um, for monitoring and maintaining indexes, it's part of the indexing process. It's not just a one-time uh, process, but it's a continuous thing. So regular maintenance of indexes is crucial for ensuring optimal database performance, and efficiency in data retrieval is there always. Even when when your data grows or your data distribution changes, or when the data patterns change, or when the concurrency of user changes, the performance must be kept optimal at all times. So it is very important to continue monitoring and suggesting new iterations, new improvements. Automatic index tuning, while it's enabled, it keeps observing and analyzing your workload and the usefulness of your existing indexes. And it keeps proposing new recommendations as the circumstances change, whether it's the volume of data, its distribution, or the type of queries you're running. And the system not only continues identifying underperforming queries and unnecessary existing indexes, but it suggests which new indexes can be created, which ones could be dropped to improve the overall database health. So those are the adjustments um, that you can uh, do during the iterative process. Um, the feature is accessible and can be operated at scale by means of it's integrated into both the Azure portal and CLI. So we are not just making performance tuning smarter, we are making it accessible and scalable. Whether you prefer a visual dashboard or a command line pipeline, you can now optimize PostgreSQL indexes with confidence, speed, and control. And now we're gonna switch over to a demonstration in which I'll show you where and how you can configure index tuning, automatic index tuning, and how it will surface recommendations, and how you can apply those recommendations. So let's switch to the demonstration. So what we have in front of us right now is an instance of Azure Database for PostgreSQL Flexible Server. Um, in the resource menu, down under Intelligent Performance section, there is a menu handler to index tuning. So if you click there, you have index tuning page from where you can enable or disable, or you can configure the tuning settings of index tuning. But to enable index tuning, you can do so from here or from here to configure the different settings that it offers. You can select tuning settings and um, um, change any of those multiple settings, and even enable it from here as well. So It's as easy as clicking that button and it will be configured with the default parameters. Another way to configure um, an index CNN is by using the CLI. So you can do um, you can use the Postgres flexible server index CNN command grip, and then you can do, for example, show um, point to a particular uh, resource group, a particular server name, and it'll tell you whether indexing is enabled or not. It's telling us it's enabled because we just enabled it from the portal. We can also disable it from here. And if we go back to the portal experience to see how it looks like, it'll now show as disabled again, giving us the option to enable it one more time. Now we'll move to an instance in which indexing has been enabled for a while, and it has been monitoring the workload that was running on this server, and it has even produced certain recommendations. So if you visit the index tuning page of an instance with all those conditions, then you have a summarization page here in which it tells you the index tuning is enabled, the tuning frequency currently configured, meaning that every hour it'll wake up and analyze the workload that was captured during the previous hour. If it's configured to 12 hours, for example, it would just look back 12 hours, the workload that was recorded during the previous 12 hours. And it'll focus on the queries, the least performant queries. And it will suggest what indexes can be created, what indexes should be dropped because they are not used or because they are duplicate of some other index, or which indexes need to be rebuilt because they are invalid and there are no duplicates of those. This is the summary view. If you click on this one, you get to this detail page where you can sort, search, or filter by any of these columns. And the two recommendations types are create index or drop index for now that we are seeing here. And for each of them, we have different attributes. For example, for drop index recommendations, we cannot compute the improvement percent. However, we can compute, given the size of the index, we know how much space we might save. For indexes that we're recommending to create, we can also compute an improvement, a hypothetical improvement percentage based on the queries that would be helped or would be optimized by any of these indexes and by how much. So if we, for example, look into this one, this index is being recommended for this reason, because this column appears in a join clause of a query with this ID, or it appears in a join clause of a query with this other ID. These are the two queries. As you can see, the improvement in each of them is very different, drastically different, but it would benefit both of them. And it's up to you to get this recommendation unapplied. We keep track of, we automatically produce a name for the index. We keep track of the object for which the index is being recommended. The columns contain or referred by the index. And when this recommendation was emitted for the first time, when was emitted for the last time, most recently. For drop index recommendations, we simply give you the reason why we are suggesting to drop this index. And in this case, it's because it's a duplicate index of another one, which already exists. But that one has a shorter length compared to this one. And that's the reason why we suggest to drop this one. Okay. Their recommendations can also be queried from using Azure CLI, and there is in the index tuning command group there is another command which is list recommendations, for which you can filter for a given recommendation type, like create index or drop index, and this will retrieve all the recommendations accumulated in this particular server of that given type, and it returns a JSON payload which you can process programmatically, and you can extract from here whatever amount of details, the same details that are surfaced via Portal. So things like the reason why this is being recommended, the script, the query IDs of the queries that would be improved, the estimated impact of this index in those queries, and the estimated impact in size. If the index is created is estimated to occupy this many megabytes, and so on. So this is it about listing recommendations via CLI. Now, if we go back to Portal and we navigate through the different settings that you can configure for the feature, not only you can decide how often you want the tuning sections to run, but for create index recommendations or for drop unused index recommendations, you can also configure some settings that control how those two algorithms that decide the creation of new indexes or the removal or the suggestion to remove some existing indexes, how they should behave. So for example, for create index, maximum number of indexes that you want to be recommended in a single session, maximum number of index columns, index key columns that any recommended index should have. What is the maximum total index size compared to the total disk space of the database? Minimum estimated regression, maximum estimated regression, and minimum estimated improvement, so that we only recommend indexes that at minimum improve, hypothetically improve the performance of at least one query by 20%, and never ever regress any existing query by more than 10%. That's what these two settings mean. The maximum number of indexes per table that would be recommended, and how many queries in the worst n queries that the tuning section will focus. By default, it's 25, but this is adjustable also to, you can lower it down to 5 or increase it up to 100. Likewise, for drop unused indexes, you can change some of these settings. So, something more, once you apply those changes, those recommendations, let me pick some of those recommendations. For example, from this one, we can pick some of these indexes, and we can bring them to Visual Studio Code with it. Visual Studio Code with the PostgreSQL extension for Visual Studio Code, which is currently in public preview, and you can queries for views based on which index tuning does the analysis. So index tuning relies on query store. Query store is where we record all the activity what queries you have run, what is the query text of those queries, if those are parameterized queries, what are the values that you pass for the parameters. If you configured a search path, we keep the search path that was used in the context of the execution of this query so that we can understand when this query was executed, what were the different locations or the different schemas that were used to the binding of the different objects. So with this, you can retrieve the text, for example, of the queries, the query text, which is something that for now you cannot get through an external API or the portal for privacy reasons. This is considered PII information. So in order to get the query text, you must connect to the database to retrieve and have the permissions to connect to the database so that you can retrieve the query text given the query ID. Otherwise, from the portal or from CLI, the only thing you get is the query ID, which to correlate to the query text, you need to be able to connect it with the database. So you can do that for the different query IDs that we retrieved from portal or CLI to identify which queries are those. And there's also a schema in the Azure SIS database, which is called intelligent performance and has sections as an object. So this will enumerate all the sessions, all the tuning sessions that have been executed in the context of this instance, when they were executed, and how many recommendations were emitted on each of them, on each of the sessions. And then there is another object, which is recommendations. So for each session, it might produce known or many recommendations. So when recommendations are created, they're surfaced through the recommendations view, from where you can get things like you have for each recommendation, all the statistics about it, and an object called recommendation context, out of which you can pick, is a JSON object out of which you can pick things like the script or the query IDs of the queries that are improved by if you would create this index. And this is basically it. So if you want to create an index, you simply pick the query, the script that we provide, and you can run it. This wouldn't work here because I'm not in the context of I'm not in the context of the database in which I have to create this, but it's just a matter of connecting to that database and run the create index script to get the benefit of the improvement. And then you could come to back to the portal, and under intelligent performance, you have the query performance insight, which if you have properly configured, you could monitor what was the impact. I mean, manually or visually, you can see what is the impact after having created that index, how your workload would improve after having created that index. Okay, and with that, we can come back to the presentation part to talk about the value proposition of automatic index tuning. So the value proposition of this feature is implementing effective index tuning enables databases to accelerate query performance significantly and reduce the response times. That directly enhances the user experience, allowing users to access data quickly and efficiently. And higher query performance translates to increased productivity of applications relying on your Postgres databases, improving your overall business workflow. So the other thing, the other benefit in the value proposition is reduced manual effort. So this automated feature simplifies the process of index analysis and tuning, minimizing manual intervention. And with reduced manual effort, database administrators and developers can dedicate more time to strategic initiatives and project planning rather than this manual work. And it also has a component related to optimized resource utilization. So with properly tuned indexes, you can significantly improve the database performance by optimizing how data is accessed and retrieved. Um, Queries that access the data through those optimal indexes typically uh, lead to fewer I/O operations, and it enhances the overall system efficiency and reduces the latency of your workload. And it also directly, by optimizing the resource usage, your business can significantly lower costs associated with resource consumption and operational inefficiencies, like the amount of uh, money that you pay for the compute, for the CPU power, or for the amount of memory that is required, or the um, uh, power of the disks that are attached to your servers. If you reduce I/O operations significantly, then you can have like uh, not so um, good disks. You live with um, lower end disks. Um, and as a conclusion, index tuning is crucial for enhancing the performance of databases. And Azure Database for PostgreSQL offers a smart and easy way to tune your indexes automatically. With deep integration into the Azure portal and CLI, you can monitor, analyze, and optimize your indexes based on real workload data. It's like having an automated assistant for performance tuning, one that speaks fluent SQL and works 24 by 7 to make your database faster and leaner. And by the way, stay tuned because we are soon extending the functionality of index tuning to also provide table level recommendations. We keep investing in this feature and we are extending the scope of it and improving the functional aspect of it. So with this, I hope you liked this session and the content shared here today with you was valuable to help you work better and smarter. Thank you.